So we are going to suppose that theta is an angle in standard position whose terminal side is in the given quadrant. We want to find the remaining 5 trigonometric functions of theta. So remember, terminal side just means that that's where your angle is. So that tells us where we're going to draw our angle in. And then from there we can create our right triangle, same way we created our right triangle earlier on Thursday. So first example, we have sine of theta is 1/4 and we're in the first quadrant. So the first thing we want to do is sketch out where this is happening. So the first quadrant, where is that?
Top right.
Okay, top right's our first quadrant. So there's our angle going into the first quadrant. Okay. How do we make a right triangle out of this?
Go straight down.
Yep.
Or straight
Always go to the x-axis. So we will go straight down to the x-axis. So these triangles are drawn the exact same way as what they were drawn with our other types of problems. And then we need to figure out what the side lengths are. Well, we are told what sine of theta is. So what sides does sine represent? Okay, so sine is opposite over hypotenuse. So if sine of theta is 1/4, what should be the length of the opposite side? 1. So we'll go to our theta, go to the opposite, and label it 1. And then what should be the length of our hypotenuse? 4. Okay, how would we find our other side? Yep, Pythagorean theorem, a squared plus b squared equals c squared. So what does b squared equal? 15. So what's our missing side there? If b squared is 15, what's the missing length? Yep, square root of 15. Okay, we already have 1 as our opposite and 4 is our hypotenuse. We already got that from our sine. So that means square root of 15 would be our adjacent. And now we just want to write out what all the trig functions are. So we already have sine. So that means we need to say what cosine is and what tangent is. And then all of their reciprocals. So which function is the reciprocal of sine? Cosecant, yep. So we'll need to write down what cosecant of theta is. What's the reciprocal of cosine? Yep, secant. And then what's the reciprocal of tangent? Cotangent. Okay, well if sine is 1/4, what's cosecant of theta? 4. Yep, it's reciprocal. 1/4 reciprocal is 4. Cosine of theta. For this, we'll have to take a look at the triangle we just got done making. What would the cosine of theta end up being? Square root of 15 over 4. Adjacent over hypotenuse. So then how do we find the secant? Flip it. So we take the reciprocal. So if we take the reciprocal, we have 4 over the square root of 15. Yep, times by the square root of 15. So we have what? Good. 4 square root of 15 over 15 would be our secant. Tangent. What would our tangent be? Opposite over adjacent. So according to our triangle, what is that? Okay, 1 over the square root of 15. Okay, so times top and bottom by the square root of 15. Yep, so square root of 15 over 15. So then cotangent of theta. Yep, square root of 15 over 1 or just square root of 15. And remember when we do the reciprocals, we wouldn't want to do the reciprocal from our final tangent here because that would put the square root back in the denominator. But if you just took the reciprocal from here, it works out well. Is that okay? Yes? No? Yes? Do we need to see another example or no? No. Okay. So that's like the rest of the problems on the worksheet you guys got on Thursday. So you should now be able to finish up those 6 problems and do the entire worksheet. Okay? Turn it in tomorrow. Yep. So we are also going to talk about circular functions today. We're going to do it right now. Yep. So you will need your unit circle out. So get your unit circle out. And your unit circle should look like this so far. We will be adding on to it. Okay, so we were finding exact values on Thursday by finding the reference angle and looking at the reference angle. So for example, if we wanted to find the exact value of the sine of 150 degrees, we would have first had to have found the reference angle at 150, which is 30, and then looked at 30 degrees to see what the sine is. Okay? Well, no matter what angle we have on here, will the reference angle change? So will 150 degrees ever have a different reference angle besides 30? No, it's always going to be 30. So we might as well just go around and fill out what all these points are on the unit circle. That way, if we are given the sine or cosine of 150, we can look right at 150 to see what it is instead of having to find the reference angle. So we should have the first quadrant completely filled in, and we filled those in by doing the 30, 60, 90 triangles and the 45, 45, 90. So then we're at 120. So 120 degrees, what's the reference angle that 120 makes? 60, good. 120 minus 180 is 60. So if this is reference angle is 60 degrees, we have to refer to our 60 degrees. So what would our cosine and sine value be at 120? Yeah. 1/2 and square root of 3 over 2. And good, you guys said negative 1/2. Why is it a negative 1/2 here? Yeah, because we're to the left. So that's in the second quadrant, so we would have to go to the left 1/2 and then up square root of 3 over 2. And that's going to be our process for filling out the whole unit circle, just thinking about what the reference angle would be. So 135 degrees, what would the reference angle be? 45. Okay, so look at 45 degrees, take a look at the point for cosine and sine, and then tell me what the point should be for 135 degrees. Yep, good. Negative square root of 2 over 2 and positive square root of 2 over 2. Okay, 150 degrees, what would the reference angle be? 30. So 150 degrees has a reference angle of 30, so we can look at our 30 degree value there. So what would be the point at 150 degrees? Yep, and 1/2. So now if I asked you what the sine of 120 degrees is, what is it? Yeah, square root of 3 over 2. You can look at 120, go right up to the sine, instead of thinking about what the reference angle is and referring back. Mm-hmm.
So, like, this is on your semester. We get this on our semester final, right?
Yep, the unit circle you'll have to use on both your test, which will be on Friday, and on your semester final.
So you give us like 120, and then you want us to do that pi thing. Can we just go right off the chart? Or do you want?
You go right off the chart. So if it's asking for sine of 120, you can just look right at your unit circle and say that's square root of 3 over 2. All right? All right, so now we got the bottom half of this, the third and the fourth quadrant, to fill in, doing the same type of way. So third quadrant, good, they're both going to be negative. Our x value and our y value would have to both be negative here. So 210, what is the reference angle for 210? 30. The difference between 210 and 180 is 30. So look at your 30 degrees, and what should be the point then at 210? Negative square root of 3 over 2 and negative 1/2. Okay, 225 degrees. What would your reference angle be for 225?
Negative square root of 202, negative square root of 202.
That is definitely the point for 225. What's the reference angle? 45. So you look at your 45 degrees, and we'll just make them both negative. So negative square root of 2 over 2, and negative square root of 2 over 2. 240, what's the reference angle? 60. So look at your 60 degrees, and we'll make those both negative. So what will be the point at 240? Good, negative 1/2 and negative square root of 3 over 2. Is this making sense? Okay. 300 degrees, what's the reference angle? 300? We skipped 270 because we have 270 done already. Okay, so 300 would be 1/2, and then negative square root of 3 over 2. Why is our y-coordinates negative now in the fourth quadrant? Yep, we're going down. Our x's are positive because we're going to the right. Our y's are negative because we're going down. So what would be the point at 315 degrees? Good, square root of 2 over 2, and then negative square root of 2 over 2. And our last point up here at 330 would be what? Square root of 3 over 2, and then negative 1/2. So now this is our first, your first time seeing a completed unit circle. So for Algebra 2, you'll be able to use this for the rest of the time. Once when you get up into pre-calc, and if you ever get to calc, you won't necessarily be given the unit circle. So I'm going to show you a little pattern to help you remember it, which is how I actually remember it. So all I do is I remember the sign values. I remember the sign values, and I know what partners with which. So I know square root of 2 over 2 is always with another square root of 2 over 2. Okay, that's the same for every 45-degree reference angle. And I know 1/2 always pairs with square root of 3 over 2. So I just think of my sign values, and I just count. So I start up here. My sign value is 1. So I just think 1, 2, 3. These all are over 2. And they all have the square roots. And then I count down 3, 2, 1, 3, 2, 1. And then you count up 1, 2, 3, and then you count down 3, 2, 1. So that's a way to just remember it in the future. A trick just to quickly come up with it if you ever need to know them and you don't have your unit circle handy. And you don't feel like drawing out your 30, 60, 90 triangles and figuring it all out again. Then the other thing that you guys should have on here somewhere is what tangent equals. So what does tangent equal? Okay, so tangent of theta is sine over cosine, and we did that one on Thursday. Secant and cosecant we can find by just doing the reciprocals. So in the other one we should probably write somewhere on your unit circles what cotangent is. So if tangent is sine over cosine, what would cotangent have to be?
Cosine over sine.
Yeah, cosine over sine because they're reciprocals. So I think that's everything. So what we're going to do is we are going to find some exact values for what sine and cosine should be by using our unit circle. Yeah, that's for 12.7. And then the other thing that we will be doing is we will find periods of functions. A period of function just means it's a circular function, so it's going to start repeating itself after a certain amount. So like here, cosine and sine, they're periodic functions because if you start at 0 degrees, you go around a full time, you hit 360, but your cosine value is 1 again and your sine value is 0 again. So that the values keep repeating itself.
When would we ever use this? What would we ever use?
No, that's actually it's a valid question. There's quite a few different areas use the unit circle, particularly a whole lot of engineering and science, whole lot of engineering. So sine waves, sound waves, all of that stuff all has. All of it has this stuff. So The other thing that we really need to know about the unit circle is every point on the unit circle stands for a cosine and a sine value. So the points that we've put on here are just the points that are the most common ones used with the 30, 45, and 60 degrees. But if I could give you another point right here, and that point would also stand for the cosine value and the sine value as long as it's on the unit circle. Okay? So we're going to start some examples with this then. So this is not find what it is. I might give it to you and then you have to do something with it. Circular functions. So this is dealing with our unit circle and being able to use our unit circle accordingly. So for the first type of problem, I'm telling you point P is on the unit circle. So it is a point that's somewhere along the circumference of the unit circle, somewhere on the edge. And then we want to find sine and cosine based off of that. Okay, so point P, this is on the unit circle. So at some point along the circumference, and then we want to figure out what sine and cosine should be. And our point P is at 5/13 and negative 12/13. So does anyone think they would know what sine and cosine is? The key here is it says it's located on the unit circle. So when we are on the unit circle, what does each of these points represent? Yeah, your cosine value and your sine value. So here, this is a point on the unit circle. So what does that point represent? Your cosine and your sine value. So what would your cosine be? Yeah, 5/13 would be the cosine. And your sine would be what? Yeah, negative 12/13. Okay? That's just a matter of knowing that every point that's on the unit circle is standing for the cosine and the sine value at that point. We don't know what angle this one is at, but we do know what the sine and the cosine value are. That's just the answer. Yep. So now we're going to find exact values. So cosine of 210. So cosine of 210, you have to look at your unit circle, find 210 degrees. So here's 210 degrees. We want cosine of 210, so you look at your point that's attached to the 210 and pick out which one is the cosine. Which one's the cosine? Yep, negative square root of 3 over 2. So the cosine of 210 is negative square root of 3 over 2. How we would have did this on Thursday is we would have found the reference angle. And then we would have thought, oh, this has to be negative because it's in the third quadrant. But now, since it's on our unit circle, we can look and just write it down. Okay. You will have your unit circle. So, right. You might have to find a reference angle. So you might have to be able to sketch out an angle and find the reference angle. But anytime you want to find the exact value, you have your unit circle. That's what I would expect you to use to do it. We want to find the exact value of sine of 45 degrees times cosine of 45 degrees. So how do you think we would have to do this?
You would go, like on your unit circle, find 45 degrees at
Okay, so find the 45 degrees. And then take a look at the point that's attached to it, and what is our values? For both sine and cosine. So that's what we use. So sine of 45 is square root of 2 over 2. Cosine of 45 is square root of 2 over 2. So now how would we simplify this? Let's multiply through, right? So what's square root of 2 times square root of 2? 2. 2 times 2 is 4, so this simplifies down to a half. Let's do another one.
So they're not all going to be.
They won't all be looking right. Some of them will be look and figure out what they are, and then simplify from there. Let's do the cotangent of 480 degrees. The cotangent of 480 degrees. So cotangent we're going to need both cosine and sine for. And then 480, is that anywhere on our circle? No. So what does 480 tell us? Okay, 480 told us that we went around the circle a full time. So 360, and then we went an additional 120. So we're actually looking at 120 degrees. So what's your cosine value there? Negative 1/2, and what's your sine value? Square root of 3 over 2. So your cotangent would be the cosine value, negative 1/2, over the sine value, square root of 3 over 2. And then how would you simplify this? Multiply by the reciprocal. So 1/2 times 2 over square root of 3. What is this? What happens to your 2's? Cancel, and so we're left with negative 1 over the square root of 3, and then how do you simplify that? Yep. Times top and bottom by the square root of 3. So negative square root of 3 over 3 is the cotangent of 480 degrees. Well, we divided fractions, but when you divide fractions, it's like multiplying by the reciprocal. Is that one okay? Okay, so the next part is talking about the period of a function. So sine and cosine, they are going to repeat every 360 degrees. Okay, because we're going to go around the circle a full time, and then it's going to repeat itself. We're going to go around another full time, and then the values start repeating itself. So if I were to give you a sine or cosine graph, the period would be 360 degrees or 2 pi. That's where we would see it start repeating itself. So here I drew a graph up here, and the period is how far or long it takes to start repeating. Okay, so here's a sketch of a graph, and we want to take a look and decide when does this graph start to repeat itself. So when would it start to overlap itself, or does it start doing the same pattern? So here we're starting at 0, 0. We go up, we go down, we see we cross the x-axis again. Looks like we hit a valley, we start going back up, cross the x-axis, go back down, cross the x-axis. So when does it look like we are starting to repeat it? At pi. Right here at pi, it looks like it starts to repeat itself, so our period of this function is pi. And you can have some really funky looking functions like this, but it's just a matter of deciding when it actually starts to repeat itself. So I mean, you could have something look as crazy as right, and then if you're told that this was the point 1 here, let's see, that can be 4, this could be 6, and when you look at this and try to decide when it starts repeating itself, it starts at 1 and it goes to 6, so every 5 times it would repeat itself. Because here we start at 1 and then we see the same pattern happening again at 6, so we would subtract them and say the period is 5. Make sense?
Will all the ones that we get be with the pi?
They'll either be with pi or with numbers, depending. So just depends on what the function looks like.